what you will hopefully get out of this topic when we're done is that cost and quality are not opposites. They complement each other. That you don't have to cut costs, that when you cut costs, you don't have to reduce quality. And quality does not cost you incremental money. That when you manage your costs, you're managing your costs, but you're not changing your quality profile. Talk a little bit about the study of quality, about how do you establish a cost of quality and a cost of quality report. How do you measure quality? Well, one example of quality is customer response time. And then we'll talk about kind of a separate concept, but it's in the same unit. How do you manage constraints? So when you go to a restaurant, what's important to you? Service, food, price, reasonable price, right? You'll pay more for better, though, right? The ambiance, company, all those things are important, right? Quality is not just the food. If the food was really good and you had to wait a long time for it, you're probably not going back. If the service was wonderful and the food was bad, you're probably not going back. So quality has a lot of components to it. It is the total features and characteristics of a product or service. Is it made to specifications? Does the food taste the way you expect that food to taste? So that you're satisfied. Remember, quality is in the eye of the beholder. Just because you think you produced a quality product, if your customers don't think it, you didn't. It's that simple. And quality is not just the quality of the product at the point of purchase. It's during its use and through its life cycle. So quality does not end at the point of sale. Reputational risk. So when I worked at Goldman, we got a little plexiglass thing you had to put on top of your every VP or above had to put on top of their desk. Of all assets, reputation, once lost, is the most difficult thing to regain. So the message was, you can lose money, but you can't lose reputation. A restaurant will not survive if it loses its reputation early. And it's important to note that whether you're a cost leader or a product differentiator, quality still matters. If you're selling screws, if those screws can't support the tensile strength of what they're supposed to do, you're going to go out of business. So it's not a trade-off between cost, leadership, or cost and quality. If you manage quality right, it should help you to reduce costs, not create costs. What costs can go away if you manage your quality correctly? Excess scrap would go away. Think of the definitions we gave with chapter 18 at the very beginning. Rework. If you have quality production processes, you'll have less rework. If you produce a quality product, you have less customer support because the product works. So quality can actually reduce costs in the long run. And of course, increase revenues. If your product is perceived as a high quality product by the customer, compared to your competition, they'll pay a premium for it. And therefore, you will be able to increase revenues. So quality can reduce costs and increase revenues. We're not going to go to these websites, but the Baldrige Awards were created by the U.S. government. I'll get to it in a second. And ISO is an international quality-based organization that defines standards of quality around the world. So the Baldrige Awards were essentially created by the government to increase the prestige of certain U.S. companies, those companies that win the award, in the global eye, to increase their competitiveness around the world. ISO creates standards, two standards that I identify here. Who's heard of ISO somewhere along the line? A few of you. ISO 9000 certifies the quality control systems in a manufacturer. So if you're getting your supplies, if you're getting some goods from a manufacturer who's ISO 9000, that allows you, as the buyer of their product, to reduce certain costs. So you would probably pay a certain premium for them to have ISO 9000 certification. Because you're more confident in their product, whatever it is, first of all, you know that your product will be of higher quality, which is good. But secondly, the receiving department in your company can reduce their inspection efforts of the products that you're receiving. So you actually are able to cut costs in your receiving department. Everybody know what a receiving department is? They, as goods come in, they count it to make sure you got exactly the number that you expected, and they do some kind of inspection to make sure that it is of the quality that you expected as well. So that's ISO 9000. ISO 14000, and you kind of walk your way up these ISOs, certifies that you adhere to certain environmental standards so that you are environmentally sound. Okay. So the economics of quality outlined right here. If you invest in quality, obviously you would improve quality, or otherwise it was a bad investment. Improved quality will reduce return rates, lower warranty and service costs, lower inventory. Why would it lower inventory if you have a higher quality product? Say again? That doesn't necessarily lower inventory, because you need to have the product available for sale. But why might it lower inventory? Well, you don't need to have inventory in stock with the expectation that some of the inventory is bad, with the expectation that some of your product will need to be reworked and you have to have inventory available for rework. So you have less inventory necessary to support inadequate product. You'll lower your manufacturing costs because you'll reduce rework. You'll create a higher perceived value in the marketplace, which obviously results in higher revenues and higher market share. You'll have more satisfied customers. That's kind of the same thing. And since throughput is part of quality, the faster you have throughput time, the less first of all, you're delivering more, and second, you're carrying your goods for a shorter period of time by having faster throughput. So that comes back to lower inventory as well. So all of these different areas of quality improve your financial performance. So commitment to quality starts at the top. If the senior management's number one goal is make budget, make budget, make budget, then that's not a commitment to quality, it's a commitment to making budget, and people will tend to cut corners to meet budget. But if their commitment is always high quality product, and we also have budgets that we're going to aim for, but we don't make them the overriding concern, then you have a senior management that's got the right focus. Marketing and R&D, et cetera, are all thinking of the same thing. Ultimately, quality is based upon defining processes and standards and controls and incentives so that the entire organization is aligned to the quality product. And that's why quality is talked about as part of management accounting, because management accounting is the area that ensures that standards, processes, controls, and incentives are in fact in place. There are two general components of quality: conformance quality and design quality. Conformance quality says that the product or service performs correctly relative to its design. Design quality says you're producing the features and functions that the customer desires in the product. Two aspects of quality. So this wouldn't be management accounting without quantifying quality in some way. So the cost of quality, and there's a cost of quality report, identifies costs as preventative costs, identification, repair, and rectification. You know what rectification means? Fixing costs. Cost of quality also includes costs that are not seen necessarily in a financial report somewhere, because opportunity costs are also a cost of quality, whether it's lost production because you have to go back and do rework, lost sales because customers are dissatisfied with your product. That's an opportunity cost. Your need to have prices lower than your competitor to convince your competitors to come to you. Makes me think of Spirit Air for some reason. How many of you have flown Spirit Air? Not too many. That's a good reason for that. But in fact, Spirit Air is the only airline that, besides Southwest, that makes money on a regular basis. Okay. Somebody want to show me? You want to tell me what this means? So how do you manage quality? It starts with understanding what your customers want. So let's start with the upper left. Based upon expectations, you set goals, you define your processes, you perform your work, and you deliver your product, hopefully to your customer satisfaction. Within your processes, you identify ways to prevent problems. Those are called preventative costs. At the end of your work process, you do inspections and things like that to make sure that inadequate goods are not put out the door. Those are appraisal costs. If you didn't do a good job here or here, you might have internal failure costs, which might involve rework. And then, of course, you go out to your customer and you have a product that's not quite right. You have external failure costs. Which are the worst of these four cost categories for you to fall in? External failure costs. You want to avoid this one, both in terms of real costs and loss of business. Of course, quality, like everything else, should be managed against all four of the Balanced Scorecard perspectives. Let's look at the financial perspective first as it relates to the 4 categories of costs. Some examples of each. Preventative costs are those things you put into your processes to prevent quality problems. So you're looking at engineering, equipment maintenance, training, and testing of your new of anything that you're doing new. Appraisal costs are really about product testing and inspection. Internal failure costs are spoiled product, reworked product, or scrapped product. And any repairs that you have to do because you did inadequate preventative training or preventative work. And of course, external failure, the worst kind, higher support costs, warranty costs, and worst case scenario lawsuits. So what's the right cost? You could spend this is the cost of avoiding problems. And what it says, you could spend nothing, or you could spend a reasonable amount of money. At some point, the cost of getting to that next level becomes very expensive, very steep to improve your quality just a little bit. As you invest in preventative and appraisal costs, your failure costs, internal and external, go down and continue to go down. However, at some point, they stop going down at the rate of speed that's economically viable for you. So what you're really looking for is where do you minimize your total cost of quality, your total cost of quality, yeah. How do you minimize? That's your optimum point right there, where the total preventative costs and failure costs is at its minimum. And that's what you're shooting for. Here's an example of a cost of quality report. You have 2 years. In the first year, the year 0, your total cost of quality was $2.3 million off of $8 million in sales. 2 years later, your total cost of quality was reduced to $1.5 million off of $9 million in sales. Clearly, you did something different. And what you see in this report is that you significantly increased your preventative and your appraisal costs, the result of which your internal failure and your external failure costs decreased dramatically. It includes an opportunity cost here, customer losses. It's an approximation, and it's a pretty important approximation since it's an $800,000 improvement that you're showing there. It's the opportunity cost of having bad quality product in year 0. As with any cost analysis, you look at relevant costs. You want to find the costs that differ between the alternatives. You ignore sunk costs. You only think about the costs that are future-looking. But you do include opportunity costs as well as out-of-pocket costs. Okay, A, B, C, D, or E. What's the answer? A, B, C, D, E, F. I'm going to keep going until everyone raises their hand eventually. G. Thank you. A. So you see that conformance costs, the first two, went up, which resulted in a decrease in internal and external failures. So the cost of quality report helps management focus on what's the costs of poor quality. And it can be used to make decisions. You create pro forma reports to see how different alternatives might play out. Okay, so that was the financial perspective. Let's think about the customer perspective. For those of you who might be thinking of metrics, I don't know if any of you are, you'll see some potential metrics in the next couple of slides. Surveys, okay. Market share, number of defective units shipped, number of customer complaints, product failure rates, delivery delays versus on-time delivery, measures of customer satisfaction. In terms of the internal business approach, 3 different techniques that might be used for identifying quality problems. Control charts. Essentially, let's say you produce thin sheets of aluminum, and it's supposed to be 2 millimeters or 2 centimeters, 2 millimeters thick. And you want to see how close you are to the specified range that you're looking for. You might want to look at charts over time to see how your product is doing over time. You would use control charts to do that. So here's an example. So if your mean was 2 millimeters and you have a standard deviation, you want to make sure that you don't have many that are outliers, more than 2 standard deviations away. This case looks pretty good. You don't see a whole lot of change over time. In this example, you have what looks like a problem brewing, because you have time. It was doing pretty well. It was within a reasonable specification. But towards the end, you started to have some problems. That's a sign that your machines may need recalibrating. And here it looks like there's some kind of a process going on to get the machines right. And you see that you're tending towards a problem area here. And that would definitely require analysis. So control charts look at some kind of a defect over time to understand where you stand. Pareto diagrams. How many of you have heard of Pareto? One, good. Famous guy, early 20th centuries. Came up with the 80-20 rule, which is everywhere. The 80-20 rule is everywhere. Yeah. So this is similar to that. 20% of your customers bring 80% of your value. 20% of your customers are causing 80% of your problems. You know, the 80-20 rule everywhere. Well, it's also true as you look at when you analyze where you should be focusing. So you have a copier with problems. You rank, essentially a Pareto diagram takes a bar chart of qualitative data, and ranks it from the most observed problems to the least observed problems. And obviously, as you try to fix problems, you ought to be picking off the most observed problems first. And that's Pareto. The next diagram is a cost and effect diagram, sometimes called a fishbone diagram because of the way it looks. So you have your problems which you've identified on your Pareto diagram, and you like to understand the cause and effect of those diagrams. So you have 4 different categories: human factors, methods and design, materials, and machine factors. And you put each of your problems in each of the in the appropriate of the 4, and you keep taking them down to lower degrees of specificity or higher degrees of specificity. And when you're done, it looks a little bit like a fishbone. You know, when you take the spine of a fish with all the bones coming out, it's called a fishbone because of the way it looks. How many of you have heard of Six Sigma? Many of you. What is sigma in math, statistics? Standard deviation, right? Everybody remembers your normal diagram? Normal curve? You have your mean over here. You have 1 sigma. How much data fits inside of 1 sigma? What's that? 68%. So 68% of the area of a normal curve is within 1 standard deviation on either side of the mean. 2 standard deviations. Anybody remember that one? What's that? It's close, 95%. Generally, when you do any kind of statistical analysis, 2 standard deviations is your guideline. 3 standard deviations. Anybody remember that one? We're getting there, 99.7. 99.7% of your data will be within 3 standard deviations. 6 sigma is 6 standard deviations. And that says you want to have, your goal in a 6 sigma organization is to have your defect rate be less than whatever number, whatever percentage is all the way out here on a normal curve. It's a very small percent. So you want to have really low defect rates. Like you want to have 99.999999997% non-defects. And that's a target, right? So if you remember that other chart we had which shows the optimal cost of quality and how the costs of creating quality get much steep, preventative costs of quality get much steeper towards the end. 6 Sigma companies say, you know what, we're going to fight through those expensive costs because we think they bring enough value. It was instituted in Motorola in 1991, made famous by Jack Welch at General Electric. This is the kind of thing that you can't decide in just one business unit. It's a total corporate decision to focus on it because you're going to have to fight through corporate silos. You know what I mean by silos in an organization? You have many different units of the organization that don't talk to each other or talk very limited to each other. Six Sigma requires the entire organization to work together. And there are consultants who have built their careers around Six Sigma. And consultants are evaluated, and internal employees go to training for Six Sigma, and they receive belts, like black belts. They're certified at a certain level, aiming to be a black belt in Six Sigma, which says that they can lead projects towards that level of quality. Oh, so right there, 99.99997% error-free. Okay? Generally speaking, you can't just make an entire company Six Sigma compliant all at once. You identify specific goals that senior management has. You want to reduce the lead time for loan approvals to a certain level. Reduce any defects in your product from a textile mill. For an R&D company, reduce your pharmaceutical R&D time. For a pharmaceutical company, reduce your R&D time. To implement it, you need management commitment. You need to reward the organization for doing it right. You're going to be breaking down a lot of long-standing ways of being in the company. And so you need to reward people for accepting change. You need to train. You need to carefully select projects that can succeed. You need to break up projects into manageable parts. In my experiences as a consultant, the projects most likely to fail are the really big ones. Just too many moving parts. And layoffs should never be a goal. Cost reduction should never be a goal. Because if you want to get buy-in, you want the organization to work with you, if they believe that the goal is laying people off, it's going to be hard to get buy-in up front. Now, layoffs may be a byproduct in the end, however. So you raise the standard. Sure, that's a way to approach it where it's not layoffs, but you tell people you're going to be trained, you're going to be expecting to work at a new level of success, and so you're giving everyone a chance to succeed. That's different than making layoffs to cut costs a goal. That's Six Sigma. Okay, growth and learning. Some metrics, general metrics. The qualification and experience of your engineers. Employee turnover rate. Some measurement of employee empowerment. Do the employees have the rights to make decisions, or do they need to, everything have to be walked up the organization structure? Employee satisfaction, number of training hours, etc. are all quality-related learning and growth. Some metrics that you might see from kind of, most of these are process-related metrics. Yield. The amount of materials going in versus the amount that comes out. The higher the yield, the more efficient you are. Number of design changes. The amount of time it takes to set up your, machine uptime. The percentage of time that your machines are broken down versus up. Your company safety record. Throughput is the amount of time it takes to get a product from start to finish through the system. Cycle time efficiency related to throughput. Of all the time spent getting through the system, how much will be classified as value-added time versus wait time, or time that you're not really functioning efficiently. So this is where things like if you have a bottleneck constraint that's slowing down the process, how that relates to quality. And of course, the percent of rework or defects. Customer response time is from the moment that the customer has an order to the moment that they get the product. Number of defective units shipped, or percentage of defective units shipped. measurements of complaints, percentage of delivery delays, on-time delivery, failure rates. So these are all potential metrics related to quality. So now we're going to think about a specific aspect of quality, which is time. Time is one of the components of quality. We talked about it in a restaurant. If you have to wait too long for your food, it's a low-quality meal. So time has its effect all the way through the balanced scorecard. Financial measures, you'll lose revenues. Think of the restaurant. You'll carry inventories for longer if it takes longer to get product through the pipeline. Ignore the third one. Customer measures, customer response time. How quickly are you able to deliver to a customer's needs? And what's your on-time performance rate? How long does it take to manufacture your products? These are internal business processes. Idle time at bottleneck operations. So you'll have these constraining operations. You want to make sure that your constraint process, whatever that is running full blast all the time and is not waiting for product. Because that's where you really hurt your time, your throughput time. Defective units at the bottleneck operations. Give me a couple minutes. He's from the other class. Okay. Just give me a couple minutes. Okay, we got time. Defective units produced at the bottleneck. The challenge there is if you're wasting your time at your bottleneck producing defective units, you're just increasing the bottleneck. You don't want defective units to pass through the bottleneck. You want to catch them before they get there. And if you have a bottleneck operation, you want to manage the setup time for that operation. I always think of M&Ms. You make the peanut M&Ms, you make all the different kinds of M&Ms, probably going through the same machinery. You don't want to have to reset up at a bottleneck operation if that operation is going to cause you to slow down the production. You want to make sure that employees are trained with focus on how do you manage this bottleneck. How do you make sure that operation is the most efficient operation that you have going? So how do you measure time? Customer response time, we've talked about it. On-time performance. Customer response time is from the moment they place their order to the moment the order is delivered. What happens? There's the receipt of the order. Hopefully in today's automated world, this process has shrunk quite a bit. There's the wait time as that order is waiting to be processed after it's been received. There's the actual manufacturing time. And then there's the delivery of the product. Within each of these, there's value-added time and there's wasted time. Your goal is to shorten this overall time frame. Okay, so here's a little exercise for you all. Don't worry about 30-day months and 31-day months. All months are 30 days for this example. Make it easier. Using the previous slide and this information, calculate customer response time, order receipt time, and then calculate each of these times. and do it in 30-day or 15-day increments. What's the total customer response time, start to finish? What's that? When did we start? September 1st. When did we deliver? December. So September 1st to December 1st, so that's how long? September, October, November. 90 days. So the total response time is 90 days. And that's customer response time. And what's the order receipt time? How much was that?
15.
Okay. And what's the manufacturing wait time? 30. And the manufacturing time? 60. So your total manufacturing lead time.
But I'm just kidding about that. 60 days.
Oh, so this is 30 and this is 60, like that? Okay. And then your delivery time, which is not to scale. Is that another 30?
15.
So, oh, okay, yeah, that fits. Okay, so there you have the whole story. Which of these times would not be value added at all? This one is definitely not value added. Order time, there may be some value added and some non-value added time in there. And certainly delivery time, there'll be some value added, potentially some non-value added. And in here, some. But wait time is non-value added. So here's a chance to calculate the manufacturing cycle efficiency, which is value added time over total time. It's going to take some assumptions here. So make your own assumptions. And what do you think the manufacturing efficiency is? Manufacturing cycle efficiency. Is this evaluated time? Yeah, let's assume that is. How about moving from process to process? It's got to move, right? There may be some inefficiency in there, but let's assume it's efficient for the moment. I don't know how else to assume it. Storage, that I'd say is not value-added. Waiting for inspection? No. It's waiting for inspection. So out of a total of 13, you'd have 8 out of 13. That would be your efficiency. If you don't believe that is efficient or value-added, it could be 4 out of 13. So that would be your cycle time efficiency. The speed of delivery may be affected by some uncertainties. If you have kind of random purchasing cycles, you're probably not going to be staffed up for the kind of the highest case scenario. So when you have some randomness to your customer's purchasing cycle, you will probably have a longer time to delivery because your staffing levels will not be able to handle peak needs. If you have bottlenecks, clearly as you hit your peak needs, those bottlenecks become exacerbated. Does everybody know what a bottleneck is? I've been using it a lot. Can you visualize a bottle and the neck of a bottle? That defines how fast the liquid comes out of the bottle. That's why it's called a bottleneck. And so you need to manage that bottleneck. So when you have uncertain demand, you want to have as much excess available capacity as possible to handle those worst case scenarios. You want to understand your bottlenecks, and as you manage your capacity, you manage whatever you can to widen that bottleneck, whether it's getting additional equipment, getting your current equipment up to speed, hiring new employees, whatever it is, you manage those bottlenecks. And you try to work your organization so you reduce your setups. The fewer the number of setups, the faster you'll be able to process. So the theory of constraints, something we talked about in the very first day of this class, you may or may not remember, is a way to maximize your income by managing your bottlenecks. To do that, first you have to identify the bottlenecks. A pretty good signal that you have a bottleneck operation is that you have a lot of inventory, either raw materials or partially finished goods, partially complete goods, waiting to be worked on. That's a sign that you have a bottleneck in front of it. You need to assume that that bottleneck is the deciding factor for the entire process's throughput. So this is how you want to manage the bottleneck to get rid of as much of that non-value-added time as possible. So your goal is to keep that bottleneck operation busy. Maybe you make them work day and night, run it 24/7. And you subordinate all of your other operations to the bottleneck operation. And then finally, you do redesigns to make them more efficient and have a higher capacity. So ways to relieve a bottleneck is you get rid of any idle time there is. In the management consulting world, at different points in time, programming or developing of a computer system, programming could be the bottleneck, or system testing could be the bottleneck. Or more than likely, it's programming leading to system testing. I've been on projects where the programmers work during the day and the system testers work at night, or vice versa. So you're keeping the whole thing going 24 hours, feeding off of each other. If you've outsourced your programming to India, let's say, that's an opportunity because their night is your day, etc. So every night the programs are written, every day the testing is done, and you have a 24/7 cycle going on that way. So you manage your bottleneck to really improve the throughput. If there's anything that does not absolutely need that bottleneck operation, you move it out from that operation, maybe even outsourcing it to somebody else. We talked about reducing setup time and improving quality. The higher the quality of your bottleneck operation, the less likely you'll have rework there, the less likely that you'll have breakdowns in there, and so therefore it will be less of a bottleneck. Okay, quarter of. We're going to finish all four today.